Hi and welcome to video 2 of 2 videos for section 3.1. In this video we're going to be looking at the maximum and minimum values, maybe I should put and or, maximum or minimum values of a quadratic function. So, if you remember at the end of video 1, we drew that graph. It was a parabola at 3, 5. So we had what? Because it was pointing upward, we don't have a maximum value because the thing's going to go to infinity. But we do have a minimum value at the vertex, at the bottom of the parabola. So that's the information we can use to say that in general, if f of x is equal to a quadratic function in standard form, so ax minus h squared plus k, then the max or min occurs at our value of x equals h. So if you remember this, it was 2x minus 3 squared plus 5. So the minimum occurs wherever, this is our h value, so wherever x is equal to h, so wherever x is equal to 3, that's where the minimum occurred because it was pointing upward. And so if a is greater than 0, meaning that parabola is pointing upward, the minimum value of f is f of h, which is just equal to k. So if I plug in 3 here, so I know that my max or min occurs at x equals h. If I want to know what that value is, well, that's when x is equal to 3. Plug that in, this becomes 0, so this whole piece is gone, and the only thing that's left is 5. So the minimum value of this entire function is 5. I'll never get a value less than that. And similarly, if a is less than 0, so if a is less than 0, it's a parabola pointing down, so that means what? That means I have a max value. And that maximum value of f is also at f of h, which is equal to k. So the only difference is a positive, it's pointing up, so I have a minimum value. And it's a little counterintuitive because you think, oh, a is positive, it should be a maximum. No. A is positive, so the parabola is pointing up, meaning I have a minimum value. And if a is negative, it's pointing down, and I'll have a maximum value. So let's look at an example. Two-part example here. So express f of x is equal to 5x squared minus 30x plus 49 in standard form. And then 2, sketch, sorry, this is a 3-part one. So sketch f of x. And the third part is find the max or minimum value of f, or of f of x. So, part 1, part 2, we did at the end of video 1 an example like this. So what I would say is if you really want to get the most value out of these videos, hit pause here and try it. Go back to your notes from the end of video 1. Try to see if you can work it through to get what the standard form is. Because just watching the videos and copying down notes, you're not really learning it. You need to practice, and that practice is by doing it yourself. So give that a try. Hit pause, see if you can express this in standard form. See if you can sketch it, And then based off of this information, if it's pointing up, it's a minimum value. If it's pointing down, it's the maximum value, and it's just whatever that value of k is. So go ahead and do that, hit pause, give it a try, come on back. All right, so hopefully you had some success. We're going to write this guy 5x squared minus 30x, leave some space here, and then plus 49. Again, remember, this has to be a 1 in front of my x squared, so I'm going to factor out a 5. I get x squared minus 6x, and again, plus 49 outside the parentheses. My b is minus 6. 1/2 of b is minus 3, so that value squared is positive 9. So I add 9 inside the parentheses, but I didn't just add 9 to the whole expression. I added what? 5 times 9, which is 45. So because I added 45 to this whole line, the only way to keep it the same as the original is to subtract 45 outside the parentheses. So now I have what? I have 5. I can rewrite this as x minus 3 squared. And 49 minus 45 is 4. So that's my function in standard form. The sketch of this, well, my vertex is at what? My vertex is at, I see negative 3, so that's plus 3. And then negative 4, because it's outside the parentheses, I'm not worried about the opposite, I just take that value as it is. So the vertex is at 3 units to the right, 4 units down, so right here, and because my a, the 5, is positive, this is a parabola pointing upward. And again, you can see I'm not necessarily worried where is it crossing the x or y intercepts. I just am looking for a sketch telling me basically it's a parabola pointing up. So now because it's a parabola pointing up, so that was part 2, part 3 is what's the max or min value? Well, because it's pointing up, we have a minimum value, and that's going to be at whatever my value of k is, which is negative 4. So the minimum value that this function ever takes is equal to, sorry, you're all screaming at the video, wait, I know. 49 minus 45 is what? Positive 4. Sorry about that. So check your work, right? Again, my apologies on that. So vertex is at 3 and positive 4. So up here, so that's what we get. And so the minimum value of this function is at this value of k, which is positive 4. So our minimum is equal to positive 4. So sorry about that. 49 minus 45 is positive 4, not minus 4. So that was a lot of work to figure out what the maximum or minimum value was. So if you're given a problem, maybe it's in your job or maybe it's on an exam, and it's saying, what's the maximum or minimum value of this function? Well, to go through this whole process is pretty timely. So is there a shortcut? The answer is yes, there is. And the shortcut is as follows. The max, and this is something I would put on your cheat sheet, or min of f of x equals ax squared plus bx plus c occurs at x is equal to negative b over 2a. So this tells us the value of x, where the max or min occurs. So then in order to find out what's the max or minimum value, we would have to plug that x into the function and then calculate the numbers there. It's a minimum if a is greater than 0. It's a maximum if a is less than 0. So if we look at this example here, the max or min, so example revisited. If I just wanted to know what's the max or min value, well, the first thing I have to do is figure out what's my value of x where the max or min occurs. Well, that's when x is equal to negative b, which is negative 30, so make sure you include that sign, over 2 times a, which is 5. So negative times negative is positive. So 30 over 10, which is 3, which happens to be what? Our x value of the vertex. Now that we know x is 3, we can plug it in. Because a is positive, we know it's a minimum value. And if I figure that out, so f of 3, it's 5 times 3 squared minus 30 times 3 plus 49, which is what? 3 squared is 9 times 5 is 45, minus 3 times 30 is 90, plus 49. So 45 plus 49 is 94, minus 90 is 4, which is the same value that we got by going the long route, factoring out the 5, completing the square, factoring it, figuring out our vertex. So, let's do another example. Let me have you guys give this a try, and again, best way to make use of these videos. I'll put this example up now. Go ahead and hit pause. Try to work it out using this information we just did with that problem there. So we want to find the max or min, you tell me which it is, of first f of x is equal to x squared plus 4x. So again, go ahead and hit pause, try to find this max or minimum value. All right, welcome back, hopefully. So our a is what? Our a is 1. The 1 in front of the x squared. It's positive. That means it's going to be a parabola pointing up, which means we're finding the minimum value. That occurs at this guy here. So the minimum is at x is equal to negative b, which is positive 4, over 2 times a, which is 1. So this is negative 4 over 2. 4 divided by 2 is 2. So this occurs at negative 2. Now again, be careful. That's not our minimum value. That's where it occurs when x is equal to that point. So if I plug that in, f of negative 2, I get negative 2 squared plus 4 times negative 2. Negative 2 squared is positive 4. 4 times negative 2 is minus 8. 4 minus 8 is negative 4. So the max or minimum value of this function is a minimum which has a value of negative 4. No matter what other value I plug in for x into that function, is the value ever going to be less than negative 4? All right, let's try one more. So find the max or min of g of x is equal to negative 2x squared plus 4x minus 5. So again, please hit pause. We've done a couple of these examples now. I want you to try this. Feel comfortable about solving these kind of problems. When you have it worked out, come on back. All right, welcome back. So our a is less than 0. That's our negative 2 here. So that means what? That means we are finding a maximum value. So no matter what value I get at the end, I can't plug any other value for x into this function and get a bigger value than what I'm about to find out. So we have what? The maximum occurs at x is equal to negative b, which is positive 4, over 2 times a, which is negative 2. So that's a negative 4 over negative 4. Negative times negative is positive. 4 divided by 4 is 1. So this maximum occurs whenever x is equal to 1. So if I find out g of 1, that's minus 2 times 1 squared plus 4 times 1 minus 5. 1 squared is 1 times negative 2 is negative 2. 4 times 1 is 4 minus 5. So negative 2 plus 4 is positive 2. Positive 2 minus 5 is negative 3. So the maximum value that this function ever takes, I can plug in 1,000,000 for x. It's never going to be bigger than negative 3. That's my maximum value. Lastly, for this video, just a quick reminder about our intercepts. So to find the y-intercept, we do what? We set x equal to 0 in the function and simplify it. And to find our x-intercepts, we set the entire function, or y, equal to 0 and solve for x. So again, might need that in the homework, might need it in the upcoming sections here, so I just wanted to remind you of that fact now. So that's it. That wraps up video 2. That's the second of the 2 videos for section 3.1. Come on back and we'll look at section 3.2.